Assalamu alaikum wa rahmatullahi wa barakatuh. Today, my presentation about speech processing for COVID-19 identification using deep learning. Automatic speech recognition, as it is known in short, is a technology that allows humans to use their voices to speak with a computer interface in a way that, in its most complex form, resemble an ordinary human conversation. Nowadays, the world suffers from the problem of coronavirus epidemic, and we can also use ASR to diagnose the disease by analyzing patients' respiratory problems such as voices, coughing, and sneezing, so that we can diagnose the disease in an easier and less costly way. Coronaviruses are a well-known family of viruses that cause disease in humans or animals. The new type of coronavirus, COVID-19, was first discovered in Wuhan, China. However, the virus has recently spread widely in most countries of the world and is said to be a pandemic. Moreover, at present, all countries of the world are seeking to control the coronavirus COVID-19. A confirmed COVID-19 patient is manifested by fever, fatigue, and dry cough. In particular, many techniques can be used to detect preliminary results of the virus, such as medical detection kits. However, these devices are quite expensive and take a long time to install and use. In the aftermath of the COVID-19 pandemic, comprehensive coronavirus testing has proven essential for governments to monitor disease spread, isolate infected individuals, and effectively flatten the curve of infection over time. However, the pharyngeal swab test is a physical invasion and must be performed by a trained doctor. Ideally, the test will be performed non-surgically at no cost and administered in the homes of potential patients to reduce the risk of contamination. The World Health Organization has reported that 67.7% of COVID-19 patients exhibit a dry cough, meaning that no mucus is produced. Unlike the typical wet cough that occurs during a cold or allergies, dry coughs can be distinguished from wet coughs by the sound they produce, which raises the question of whether the analysis of the cough sounds can give some insight about COVID-19. Such cough sounds analysis has proven successful in diagnosing respiratory conditions like uh, pertussis, asthma, and pneumonia. Through this project, we suggest making a use of signal processing, widespread computing, and machine learning to develop a program to check COVID-19 by recording an audio clip of their cough, and then we use audio signal processing and machine learning techniques to check and diagnose positive conditions for patients with COVID-19. Problem statement. The World Health Organization has reported that 67.7% of COVID-19 patients have a dry cough, which means that mucus is not produced. Unlike a typical wet cough that occurs during cold, dry cough can be distinguished from wet cough by the sound they produce, which raises a question of whether analysis of coughs sounds can give some ideas about COVID-19. This analysis of voices has proven successful in diagnosing respiratory diseases such as whooping cough, asthma, and pneumonia. A confirmed COVID-19 patients manifest in fever, fatigue, and dry cough. In particular, many techniques can be used to detect the preliminary results of the virus, such as medical detection kits. However, these devices bear a heavy cost and take a long time to install and use. Through this project, we seek to design a system that can analyze the cough sound and find positive cases for patients with coronavirus without cost and in a short time. Our objectives is to design a system that can detect the positive cases of COVID-19 from coughs and to evaluate the accuracy of the system. Our project scope is to detect coronavirus using voice recognition from the collected data. Our project aim is to detect coronavirus patients using voice recognition through microphone. And here is our literature reviews. Our literature review. There are many research has been done about detecting of coronavirus. Some of them they used the microphones through voice recognition, and some of them they use CT scan image for the lungs, and so on. And here's our methodology. First of all, we create a database that contains the information that already contains the information about COVID-19 patients and about COVID-19 patients. And then for the new voice records, we use signal processing and artificial intelligence. First data cleansing. As the recordings were collected in the wild, there were few unsuccessful recordings where the patient failed to provide any speech rather than noisy backgrounds. In such cases, we will use one of the Python libraries such as Pandas library for data cleansing. Voice activity detection. For some recordings, there were silence periods for the first few seconds and or the last few seconds. We only remove the beginning and the end of unvoiced parts from each recording where no audible breathing took place. Hence, only voiced segments, speech, breathing, and coughing from the recordings were maintained. Speaker diarization. Among the remaining voice segments, there is a speech from other individuals than the targeted patient. For this reason, we manually checked and mentioned the speaker identity for each voice segment, indicating if the voice was generated by the patient or by anyone else. The speech transcription. After mentioning the speaker identities, voiced segments from the targeted diagnosis patients were converted into text transcriptions. While the collection was in the wild, some recordings were spoken by the patients, but with impromptu and unwritten content.